Photovoltaic systems, PV systems for short, are the most important renewable energy source in Germany alongside wind power. 2020, 45.1 terawatt-hours of PV electricity was generated in Germany, which is around 9% of the total electricity generation. The biggest criticism of PV energy is its heavy dependence on weather, which is not always sunny in Germany, and the resulting strain on the electricity grid. By the end of this video, you will have understood to what extent this criticism is justified and what can be done about it. You will learn how a PV system is constructed and how it works. In addition, we will clarify the question for whom it is worthwhile to have your own PV system. First, let's take a look at the structure of a PV system using the example of a typical system on a single-family house. The most important part of the PV system is the PV module itself, which is mounted on the roof. The more accurately the roof is orientated towards the south, the better. Usually, several modules are used which are connected either in parallel or in series. Each module generates a DC voltage as soon as a certain amount of light shines on it. The second part of the PV system is the inverter, which is often located in the basement or in another protected place. Depending on the circuit, the modules are connected to the inverter with one or more cables. In larger PV systems, several inverters are used. The inverter is necessary to feed the direct current of the PV module into the 50 or 60 Hz AC grid in the house. Let us now turn to the function of the system. The PV module is usually made of silicon, which is a semiconductor. The so-called photoelectric effect is used to generate energy. Simply explained, this photoelectric effect means that in certain semiconductor materials, the impact of photons causes a voltage to be applied to the material, which in turn leads to a current flow via a connected consumer. This energy is harnessed by the PV system. Here is something from the category of useless knowledge on the side. Albert Einstein received the Nobel Prize for the scientific description of this photoelectric effect, not, as many think, for his world-famous theory of relativity. If you're interested in more such useless knowledge, subscribe to the channel now and activate the bell. In the past, the inverter was usually connected directly to the grid via an electricity meter. Thanks to public subsidies for PV technology through the Renewable Energy Source Act, up to 57 cents per kilowatt hour was paid for the energy in Germany. Despite the rising electricity prices since then, this is still significantly more than the consumption price, which is averaged around 40 cents at the moment. Which means that it is still worthwhile today to feed these systems into the grid. However, if you receive less money per kilowatt hour, currently around 8 cents per kilowatt hour for new systems, which is significantly less than you pay for it, it is worth consuming the electricity yourself. For this reason, an additional battery is sometimes installed. The entire system is then operated in such a way that the surplus energy from the PV system that is not currently needed in the house is fed into the battery. An example of this is the feed-in of a PV system on a sunny day. Here you can see the feed-in assuming a highly simplified constant power consumption during the day, and at night energy is fed into the battery in the red shaded areas and energy is drawn from the battery in the blue shaded areas. Ideally, the entire self-consumption is covered by the PV system. In practice, however, this only works on sunny days. If the PV system were dimensioned so large that the entire electricity demand of the house could be covered, a very large battery would be needed, which could be neither sensible nor economical. One way to install a larger PV system and use the electricity is to add electrical consumers. In a new house, for example, a heat pump. This uses ambient heat or geothermal heat and electricity to generate usable heat for heating the building and for hot water consumption. For example, for showering. This increases the electricity demand and, at the same time, no further primary energy source, such as gas or oil, is needed to heat the house. The purchase of an electric vehicle can also increase the electricity demand. On the subject of electric cars as the future of mobility in Germany, I have also created a video that I can link to you in the info card. The optimal solution for the size of the PV system and storage unit depends heavily on factors such as the size and length of the house, the orientation of the roof, insulation and heating, and many other factors. In conclusion, it can be said that PV technology is also an important part of the energy transition in Germany, even if the number of hours of sunshine per year in this country is significantly lower than further south. In most cases, a combination with other technologies such as storage, heat pumps, or electric vehicles is necessary and also makes sense. In addition to the environment, PV systems are usually also worthwhile from an economic point of view. Even if the entire system with storage is not cheap to purchase, the system pays itself over the period of use and the capital costs are usually favorable due to subsidies and loans. Local storage solutions optimized for self-consumption are not ideal from the point of view of the overall system, but they are still profitable in the current market. If you like the video, give it a thumbs up and subscribe to the channel so that you don't miss any more videos.